My name's David Cordes. My co-presenters are Cherry Lynn and John Quinn. And we're going to talk about high availability disaster recovery and backups. To level set us, to make sure we're all on the same page, I want to talk about what we're trying to prevent. We're trying to prevent the risks of data loss and downtime, right? If you lose your data, that has a real cost on your business. If you have downtime, it has a cost on your business. So all these strategies are designed to minimize this. This is something everybody wants, but maybe not everybody can afford, or they have to make trade-offs. So we're going to talk about what things you can do that will help you minimize these risks. Those three approaches we're going to go over today are backups, high availability, and disaster recovery. So let me define what I mean by these things. The backup, I think most people have a sense of that. It's a snapshot of your system written to a file, and you can later, if you want, go back to that point in time. So if I took a snapshot on Sunday and I want to go back to my system in the same state as it was on Sunday, I could go back to that. That's what a backup is. High availability, which I hear this term used a lot. What we mean here is that there is no single point of failure, meaning that you have machine redundancy. What I mean by that is if one machine goes down, your ArcGIS server, your portal, will just continue to run. And we'll show you how to achieve that. Disaster recovery is, again, no single point of failure, but the level we're working at is an entire environment. So like your data center could be underwater. Hurricane Katrina wiped out your data center. You need to run somewhere else. Well, you have a whole redundant environment somewhere else, geographically located away from your first data center. That's what we mean by disaster recovery in this session, and we'll talk about how to achieve that. Now, one of the questions, the first question most people ask when we introduce our technologies, especially when there are several different approaches, is which one should I use? And in this case, I'm here to tell you that you can use all of them if you want. They're complementary. You can have a highly available system and do backups. In fact, I would recommend it. You can use disaster recovery, high availability, and backups. You can go for the whole 9 yards. In fact, they build off of each other. Like what I would say is everybody here I would recommend do backups. And we'll talk about that in a second. A lot of you probably can do high availability and backups. And then some of you may even want to do all three things. So they kind of build up off of each other. The only reason you wouldn't choose them is because of cost or capability. It costs money to have duplicate machines or duplicate data centers. And obviously there's a lot of operational know-how, a lot of operational effort that goes into managing these systems. So that depends on whether you guys have the resources to make that possible. So the way we've organized our section is we're going to talk about it in three different areas. We're first going to talk about backups, then we'll talk about high availability, and then we'll talk about disaster recovery. So I'm just going to state I love backups. I actually think they are the coolest way to get any kind of prevention against data loss and downtime. And the reason I like them is that they are simple. I feel like sometimes simple solutions, they don't get the press. The highly technical, complicated new thing that somebody just came out with, they have a press release and they took out Computer World to cover them. It's on the front page. All the IT CIOs are talking about them. Nobody talks about backups because we've had them for 30 years. But if they just came out today, I guarantee you that Oracle will be saying, we have backups, and it'll be front page news, and Larry Ellison will be announcing it at the Oracle conference. And that's because they're highly effective. Backups are awesome, right? You can go back to a point in a snapshot in time, and part of that is because they are simple. The other thing is they're not disruptive. So you can do a backup of your ArcGIS server in your portal, and while you're doing that backup, it has no effect on your operations. Your users can be accessing your maps. They can be downloading content from portal. They can be searching for stuff. None of that stuff is impacted during your backup procedure. It's not disruptive. And then finally, I think they're underappreciated. There's something that I think people don't appreciate enough because they aren't cool or sexy anymore. Finally, I want to say, and I should have a fifth bullet point on this, is that they are cost effective. I mean, this is the only approach that doesn't require you to purchase more machines, more licenses of software. This is something where you run a simple tool, it produces a file, You store it away on a rainy day, and then when you have that disaster, you restore from it. There's no need for additional machines or additional cost. The only cost is your time in setting this up. And I'll show you how to do this, and it won't be too expensive, hopefully. Now, when we're talking about backups, Esri has a lot of software that you can install. We have a data store, we have ArcGIS Server, we have Portal, and then we have GeoVent extension, and we have geodatabases on 5 different types of relational databases, etc. So there's a lot of complex technology. And what I'm going to talk about today, the first thing I'm going to talk about is your ArcGIS Server site. That's what, if you've been using, probably most of you have been using. How many of you are using ArcGIS Server today? Probably most of you. How many of you are using Portal today? Less of you. So I'm going to mention the 2 architectures. The first is just ArcGIS Server. I have an ArcGIS Server, and I'm serving out web services. I may have some custom applications that my users are using. I may be accessing an ArcMap. I may be accessing a Pro. That's ArcGIS Server. We talk about Web GIS. We have your Portal, and that's what we're primarily talking about when we talk about a Web GIS. Now you say, why didn't you call it Portal GIS? Well, because it's more than just the Portal product. In order for Portal to work, you actually need to have a server that's backing it up, doing stuff to help the Portal work, and you need a data store that's going to be working with that server. So we said, well, what do you call those 3 components together? We came up with a name. We said Web GIS. So that's the name I'm using here. And when you do a backup of your Portal, you want to back up the server that's working with it, that's hosting all the features and your feature layers. If you have scene service cache, you're going to have a data store. You want to back all of that stuff at the same time and have it be consistent. And so what we wrote and created, we'll talk about this in a second, is a tool that backs all of that up. So let's talk about the traditional ArcGIS Server option first, then we'll go on to Web GIS. So for ArcGIS Server, here's what our tools back up. They basically back up most of the stuff you would expect them to back up. They back up your settings. So if you've set permissions on services, those are backed up. If you have users or roles in server, those are backed up. If you have if you're pointing to a particular active directory set up, users, that's backed up. It also backs up your services. So if you have 100 services published, those are backed up. What is not backed up by our tools are the cache tiles that you've generated or the data that you're serving. So if you have your data in an Oracle database or a SQL Server database, we're not going to SQL Server and initiating the backup. The best way to do that is to use the SQL Server backup tools or the Oracle backup tools. For your cache tiles, the best way to do that is do a file system backup. So this is just to let you know where the boundaries are. Because I'd hate to have you do a backup of ArcGIS Server and then find out you don't have your cache tiles when you need to restore. So how do you do ArcGIS Server backups? Now, most of the times when we do these presentations, we'll tell you the tool and the arguments. What I want to show you is not only that, but how you're going to actually use that tool. So if you want to do backups, one of the things you can do is just say, I've updated my site, and so I'm going to do a backup. That's fine, that works. But I would encourage you to do regular backups. Disk-based, for the most part, is cheap. So do lots of backups, do them daily. Now, if you want to do them daily, the way to do them is on Linux, you would do a cron job. I love Linux. This is a Linux laptop. But if most of you are probably on Windows, so I'm going to show you the Windows way to do this. And that's to use the task scheduler. So what you see in this picture is I've gone to the administrative tools, the subset of tools under Control Panel, just for administering your server. And there you'll see this task scheduler. And to set this up, it's fairly simple. If you look in the red box on the right, you'll see Create Basic Task. And what you see is you just go through this simple wizard. The first box is just given a name, just so you remember what task this is. So it's like, my backup for ArcGIS Server. The second thing is you say how often you want this to run. Probably want it daily. Third thing is what time do you want it to run. I picked like 20 minutes after midnight. Why not? And then the fourth slide is what is the tool you want to run. Now it's impossible to read that little text in that fourth box, so I've expanded it down below in that white box. And basically it's just you're running Python and you're running our backup py file. That's our backup tool. It's included in the software. It's there for you to use. And in fact, you can even move it to a different machine and it will still run. So it doesn't need to be on the ArcGIS Server machine. And then the second box are the command line arguments. Basically, all you need to do for this tool to run is you need to say, what's the username and password to log in? Because we don't let anybody back it up. It's a secure system. We need to know the URL. How do I contact that ArcGIS server? And then the fourth thing is, where should I put the backup when I'm done? And so that's what I provided here. So with that, in 5 minutes, you can go home and you can set up your backups. It really is this simple. Now let's go to the second thing. So I was talking about the backing up your server when you just have server, and that's what most of you have right now. But I think a lot of you are probably considering Portal, so it's also a good idea to understand the Web GIS backup experience too. So what do our tools back up there? Well, it's going to back up the same thing server backs up, but it's also going to back up more. So it's going to back up your settings. So you have settings for Portal, you have settings for server, and you have settings for data store. All those are backed up. It's going to back up your services, of course. It's also going to back up your Portal content. So if your users are uploading or creating web maps, those are backed up. Your users created a bunch of story maps, those are backed up. If you uploaded map packages, backed up. All that stuff that you're putting in your Portal is backed up. Also backs up the data store. Now the data store is kind of broken up to like 3 sub data stores. We need a better name for that, but one of them is relational. If you have feature services in Portal, all those features will be backed up if you back up the data store. If you are using our scene service cache or 3D style services in server, that data will be backed up. The fourth thing, or sorry, I was a math major. Third thing is we have this new spatiotemporal data store. That's not backed up yet. It's for big data, and backing up big data is not something you do lightly. It needs to be well designed. So that's an upcoming feature at some other release. Now, how to back up your Web GIS? Well, the good news is we have a simple tool. It's the Web GIS DR tool. DR stands for Disaster Recovery, and John will talk about this in a little bit more depth. But the same tool can also be used for doing backups, because we basically use the same mechanism. It's a property file. So, that other thing with the server thing, I know some of your security folks will probably have gone on the thing like you're entering what in the command line? A username and a password? By the way, for you guys, if you do have security administrators, the solution for that is to create a batch file that calls that Python thing, and then you put your credentials in the batch file. At least then you don't have something in the command line. But what we did with Portal is we said we're going to put it into a file, and we actually encrypt the password in this file. So you can have your password encrypted. And all you're telling us is where do you want to put the WebGIS output. So when I've done that backup, where should I put it? Could be big. Make sure you have enough space. I need to know the URL to Portal. I need to know the credentials because I need to log into Portal. And I need to know whether I should back up that scene cache. That scene cache, that 3D cache, of all the buildings in your city or whatever, that data probably doesn't get changed very often. You probably don't generate that very often, but the data is huge. I would recommend for most of you, if you have scene cache, don't back it up on a nightly basis. Back it up like weekly or something. The amazing thing on this property file is all the things that are not listed here, because we made the tool really intelligent. This will back up your server, will back up your data store. You didn't have to tell us on which machine the data store is installed or which machine the server is installed. It will basically ask the portal for that information, and the portal will give the tool that information. It'll go out and do this stuff for you automatically. So it's pretty slick. And then the final thing I would do is I would automate it. You can automate it in just the same way I showed you a second ago with that scheduled task. You can schedule this backup, and it will be really effective. Now the other thing is restoring, and I almost put a demo here, but it's so pointless. It's almost unbelievable because you run the tool. There's a restore.py, and you give it the file, and of course the username and password, and that's all there is to it. It's really a simple tool and that was obviously our intent. We work really. The funny thing is when you make something simple, it's taken for granted, but engineers on that team, us, work really hard to make it that simple. And we wanted to make it simple because when you have that disaster that strikes, the last thing you want to be doing is trying to look up a manual or calling support and waiting to get somebody who can help you with your problem. What you want to do is you want the tool to be simple because you're going to use it. You don't use it every day. You want to be able to pass in some argument and you want it to work. And so that's what we focused on, is making it simple, making it work and functional. So that's really all there is to restoring. So I'll take a question, yeah.
This uses a tool to migrate my ArcGIS servers into a new server as part of an operating system upgrade?
The question, I'll repeat it for the sake of the audience, is could I use this to migrate my server as part of an operating system upgrade or something along those lines? We don't have any, so the answer is, it's not a yes or no answer. There's a lot of answers between yes and no that are gray. We don't have any documentation on that. We don't do testing of that. I have heard of customers who have used it for that means. But there's a lot of variables that go into whether that's going to be successful. This tool assumes it's getting restored basically, like the server tool, to the same environment. That it's going to have access to the same databases that it did before and the same file servers. Sometimes when you do that migration, those things are changing also, and it may not work in that case. So it's a big maybe. But I'd rather be truthful than sell you something that doesn't necessarily work. So it depends on your willingness to take a risk and try that out. You know, it won't do any harm to do it. If it doesn't work, then no, it doesn't.
Those name changes, in theory, should work.
Well, the server doesn't care when it does like these backups and restores about the names of the servers changing, but it does care about all the data it accesses changing and where it stores the settings in that so-called config store. It cares a lot about those things changing on it. So some of those things can change, some of those things can't change. So yeah, there was.
Sorry, generally speaking, if the data stores and the path to where all the settings are the same,
Probably would work. Probably would work. Like I said, we don't test that necessarily as part of our workflows. That is something that we're actually trying to work on in a future release, is to make it super simple to migrate a server from one machine to another, and even handle some of those things that do change. So it's like a real solution to the problem, rather than something that kind of works. It might work. Yeah, question in the back?
Is the relational data to a service back as well? I mean, say, for instance, an FTP, which is talking to an ArcGIS service, is that backed up?
No. So let me repeat it. So is like, let's say you have a service, a map service, and it's using a file geodatabase. Is that backed up as well? And the answer is no. It'll back up like if you want to think about it, like the MXD equivalent. So it knows all the layers that you have and what they're supposed to look like, but it won't back up that data. What you'll need to do there is do a file backup. So do that file backup. And the reason we do that is on a nightly basis, your file geodatabase is probably not changing too much, but your server stuff, your server settings could change quite a bit. So you decide the frequency and the pace that you want to back up file geodatabases.
The other reason I ask is obviously if you use something like Bing to do virtual image backups, as an example, does that not negate the need to do this thing?
The question is, if I do let's say I do a file system backup or an image backup if I'm on a VM, take a snapshot. Does that negate the need to do a backup here? You know, I would say I would test it out. I mean, one of the most important lessons that you'll hear John and Sherry mention is, it's not enough just to have a theoretical process to recover. You actually have to test it out. I would try the virtual machine approach. The challenge with the virtual machine approach is that a lot of times especially with let's just say for the server, let's not do the Web GIS. The Web GIS is really hard to do with a virtual machine approach because you have to snapshot everything in a bunch of different machines in a complex environment at the same time. But for server, you could say, well, let's say I just have one machine, it's running on one VM, and my settings are on that same machine. It would probably work. The challenge is I have had people where this has gone wrong. They say, I have my settings, the config store on a file server over here, and I have two servers over here, and they backed up these things, but they didn't back up the settings. And so when they did the restore, they actually didn't go back in time because they didn't back up the settings which were on another machine. So ArcGIS Server is not necessarily self-contained. It has references to data and settings on other machines, and that's where the virtual machine approach can have problems. So that's why we built the tools to kind of make it easier for people to make that just work for them. All right. So with that, I'll hand it over to Cherry for high availability.
Thank you, David. Next, we'll talk about high availability. In this session, this is the overview. David generally mentioned what high availability we're dealing with. We'll go over some key points so we know what we are dealing with here. And then we'll talk about the high availability features of Web GIS, the portal, server, data store, ArcGIS data store. And then we'll go over some other factors, I think not necessary for Web GIS, but very important when you implement high availability. What's high availability? This is kind of like a official definition of what's high availability. Basically, it's your system or component, how continuously operation, business continuity, how good it is, right? It's measured generally like a percentage, those SLAs, those nines, how many nines your system has. And the goal of this high availability is you need a spectrum availability. Towards high availability, you want to continue your system to work. The goal is to eliminate a single point of failure. So any machine is down, your system still continue to work. And then so it guarantees that you really short downtime or almost no downtime. And even shorter downtime will cost you a lot more. These are the factors you want to keep in mind when you design your high availability. And the high availability, the availability of system depends on the availability of all the components, right? We are talking about Web GIS here, what do we do? But it also depends on other factors, your hardware, your software, your network. Just keep in mind, we are only talking about Web GIS high availability. There's other factors when your design is also very important. We will touch that at the end of this part as well. And you probably know Web GIS pretty good by now. What we are going to discuss in this Web GIS, we are going to talk about portal, GIS server, and ArcGIS data store. At the data tier, there's other data like your file data, your geodatabase, your enterprise geodatabase. We are not talking about those. For enterprise geodatabase, they have their own technologies to implement high availability. We are talking about the ArcGIS data store that's released by Esri. First, let's talk about portal, the high availability for portal. Before, let's go over the brief history first. Portal is fairly new compared to our server product. Before 10.2, we just didn't have availability. You have to just have one single machine. And then at 10.2, we had it, but you really need to go to our managed professional service, managed service to get their help. Even you are very savvy yourself, you still have to go to them because it's really complicated. And at 10.3, we released the product utility, the portal HA utility, and the documentation. Still, it's pretty complicated, but you can do it. Follow our documentation. At 10.4, we really simplify that process. I'll do a quick demo, like why we say that it's simple. That out of the box, that you can do it yourself as well. High availability, as David mentioned, on this spectrum, it's a pretty complicated, pretty high skill requirement process. It's probably still a good idea to get a professional service to help you because it's pretty complicated thing to do. But even though you are pretty savvy, you have that technical skills, you have your IT people, you can do it fairly easy after 10.4 now. This is our architecture of portals high availability deployment. In this architecture, we have two machines in this high availability deployment. So one machine down, there's no single point of failure. Your portal still continue to work. We only have two machines here instead of more machines. It's because of we do not really need that scalability. Our portal is pretty good so far. All our customers, even very use it very heavily. Customers, two machines is good enough to handle all these requests. So we don't really allow three, not because of any other reason. Just two is enough. And next. We'll do a demo. When we say we make it very simple to form this architecture, what do we mean? In this demo, what we do is if you come from a standalone machine background, you already deploy one machine portal. You know that you have one portal, you create a portal, and you have the portal content on the shared directory. That's the tree. And then in this demo, we just have the second machine join the first machine, form this two machine architecture. So what I'll do here, I already have a machine that's have a portal created. This is a portal admin app. If you've probably seen this. And we have a machine list, right? Ever since 10.4, we have one machine right here. This is the machine I have, and in this architecture, I also have my content folder on the shared directory that both machines have access to. And then I go to the second machine. My second machine is the 1805. On this machine, I want to form the high availability deployment with the first one. You've probably seen this right after you install Portal. This is what you see. All you need to do here, you just need to join this existing machine. I'll do a copy of this URL. It's asking your first machine's URL. And then the username to join that, I already remember it's, and then that's all. That's all you need to do. It's going to join the second machine, and then instead of all those steps you have to do from previous release. This is going to take about 4 or 5 minutes. It does a lot of work behind the scene. It's configured itself to communicate at different levels with the first machine, and then back and forth. All these configurations we have to do manually before this. In these 4 or 5 minutes, it's going to do. It's logged in the log file. It's a very detailed log. You open the portal log, you'll see exactly what it's doing. It's do the indexing, reindex, everything. You'll see exactly the procedure. I won't let you wait. We'll continue and we'll come back after it's done, you see. Okay. So we see the as architecture, right? So in this portal high availability, there are 2 machines, require 2 machines. And then in this architecture, both machines, in the architecture that it requires a highly available file share. That's a file server that's shared that both machines have access to for your portal content. They both behind a load balancer, high available balancer, and these 2 machines to the end user, they are equal. They both take a request. You can even say they are active to active in that case. Load balancer, load balancing between both of them. Requests come in, go to both machines. But internally, right after the machine join, you see the machine list later. You'll see something like this, these 2 machines. And internally, only you guys, administrator, you can see there is a different role. One is the first machine is called primary. The second machine is called standby. Internally, so there is a little bit different why we put this machine role here. There are different is at the downtime, right? If you have one machine is down. If your standby is down, the end user won't have any notice of that. Everything just works seamlessly after that. But if it is your primary is down, there will be like a minute, 30 seconds, a minute or 2, that the end user notice it behave a little bit weird, like kind of like a phrase, kind of like your internet is slow. It's that kind of feeling. There is an internal failover happening that these are internal details. It automatically handled, but just there's a difference to your end user experience. And we mentioned that you put a high available load balancer. The load balancer have 2 options here. One is you can use the ArcGIS web adapter. This is a product released by Esri. And this product enable you to use web tier authentication. If you want web tier authentication, you want to use ArcGIS web adapter. But this web adapter is deployed to your web server, to your IIS, to your Tomcat or Glassfish. So the high availability of this this tier depends on your web server. You need to make sure your web server is highly available in that case. And another option is you just you don't need web tier authentication. You just use a third-party load balancer. It's already a lot of products out there that this is not provided by Esri. You probably purchase from somebody else, these vendors, and usually it's already fault tolerant. And then now we put that together, right? If you don't need a web tier authentication, you just put your two portal behind a load balancer. It's pretty simple to implement because you don't have that extra tier. And then it requires a simple setting in the load balancer. It's all in our documentation. So it's easier to implement, but it doesn't support web tier authentication. In another case, right, you want web tier authentication, but you cannot guarantee your web server to be highly available. Then in that case, you can implement two web adapter. It's more complicated to implement because it's have an extra tier, but it gives you web tier authentication. Here are some key points. Let's just go over about portal. Right, it's two machines in this configuration. Internally, there's one primary, one called standby. They behave a little bit different when which machine is down at the downtime. But these are all automatically taken care of. Just a minute or two that end user notice internet is slow. And it requires a high available load balancer. You have options, either use web adapter for web tier authentication or no. But if you use web adapter, make sure there's no single web adapter in this architecture. And it requires a highly available shared content folder both machines have access to. Go ahead.
Is it possible for the administrator to control which system is standby and primary so that they can take one down for maintenance, for example, and bring it back up and then take the other one down without the user having that 1 minute delay?
The question is, do I have control? Does the administrator have control? Which one machine I want to be administrator, which machine I want to stand by? The answer is you see that the screenshot, we can go back to, you know exactly which machine is standby, which machine is primary. So you can definitely take the standby down. But when you bring it back, take a primary down, at that moment it happened again. Right, so you have control over who is who, but as long as you take a primary down for maintenance or anything, that failover happens, that minute or two still happens.
Oh, so you can't, okay.
You know, you have to have a role that's primary, one role is standby.
Right.
Okay, we talk about portal, right? Next we go to server for GIS services. Server's been there for a long time. Most of you probably know server before portal. The server has very similar architecture as portal. Some main differences, one is, server is not just two machines. We will allow you to scale up to how many machines you need. Because different from portal, server sometimes requires very computing power. It requires a lot more machines. So we do not have a limit of how many machines you want to scale to. And all these machines are a little bit different from portal as well. They are identical. They are all active. There's no primary standby. They are all active. Any machine is down, the end user is seamless. They don't notice that a machine is down. And they require a load balancer, behind load balancer, and they require the shared highly available file share for config store and server directories. And similarly, there are two deployment. One is with load balancer if you don't want a web tier authentication. And the other one is if you want web tier authentication and you cannot really guarantee your web server to be highly available, then you can implement two web servers with a web adapter, just to make sure that you don't have any single point of like a web adapter. These tiers you don't have a single point of failure. Next, we'll talk about federation. We specifically talk about this because we have we have users when they implement highly available Web GIS, they got tripped over this a lot, because it's not because it's very complicated. It's just because when you come from the standalone, deployment, you don't really notice this. You don't know this is such thing that happening. When you put a portal and a server together, right? Again, what I'm mentioning here is all in the documentation. So you just follow the steps. I just want you to keep in mind, since a lot of people didn't notice, it's not, you don't have to remember exactly what to do, but just there's such a thing that you keep in mind. When you put a portal server together, we call it a federation. What do we do there is you put these two together, set up a communication between them, right? When we do federation, for a portal, you probably know this. You have a load balancer. You serve out your items, your applications through 443, the port 443. And then Similarly, server services serve out to your end user. There's through the load balancers 443, which is internet port, right? And internally, there's administrative tasks. For example, you set your securities, you publish. You do not want to expose that to the internet. Those administrative tasks, like the way we demoed earlier, is running on 7.443, and similarly on server, these tasks are running on 6.443. When we say federation, right, when we put them together, you set up the communication between the 443 on server and the portal, so they can communicate each other's services and items. At the other hand, we also set up administrative tasks, communications through the private port, from the port of 7.443 and 6.443. So, if you might be familiar with this, when you do the federation, we ask you, what's your service URL? What's your server admin URL? And similarly, on server side, we have the settings in the server admin security settings. What's your portal's public URL? What's your portal's private URL? For the standalone machine, that's easy, right? When in the federation time, we know you only have one machine. What's your private URL? Machine name is 7.443. Machine name is 6.443. So you don't really notice that when you federate. But for the high available settings, machine name 6.443, machine name 7.443 is not going to work because a single point of failure, it goes to one machine. That machine is down, this communication is broken. What you need to do in that case is this URL also be highly available. So you need another load balancer for private communication as well, for portal and for server. This is just something you follow our doc, easy to set up, but something keep in mind. For high availability, there's another URL you need to pay attention to. So here's some key factors about server as well. It's for multiple machines for better scalability, and all machines have identical roles. They are all active and no interruptions when one machine is down. And they both require, similar as portal, it requires a highly available load balancer. Could be a ArcGIS web adapter for web tier authentication, but in that case, make sure you don't have a single web adapter. And has a highly available file share for config store and server directory. And when you federate a server with portal, keep in mind that you need these all 4 URLs to be highly available. The public one's easy to understand because you know that they behind the load balancer to communicate to the internet. Internally, it needs to be a load balancer as well for high availability. And one thing, the last session actually, the user asked, I just point out here, that one portal can federate with multiple servers, right? When you do that federation, make sure all of these are highly available when you want a highly available setting. Next, let's talk about ArcGIS data store. I mentioned that data tier, right? You have your file GDB, your file data, your shape file, and or your enterprise geodatabase or Oracle. We are not talking about those here. You are responsible for that. Like for the file, right? File data, you either put on every single machine or on the file share that's highly available. And geodatabase have their own technology. We are talking about an ArcGIS data store. User asked us if you wonder why, if you already have enterprise geodatabase, why do I need ArcGIS data store? That's not what I'm covering here, so you can come to our island, talk to our data store team that they will explain better to you. It's basically for hosted feature and tile data. We talk about how you implement high availability for the data store. So for the high availability data store, different from portal and server, they are very clearly, one is primary, one is standby. There are 2. You have a primary data store, and then you put your data store's backup file on a shared folder, and then you implement a standby that constantly streaming from primary that's ready to take over. And this is a high available ArcGIS data store architecture. And the difference is it doesn't need a load balancer. It directly communicated to the server, and then server can have a load balancer. Server knows who's primary, who's standby, and these 2 machines also knows the machines in the server side. So they knows which machine. If one server machine is down, they know which the other machine to go to. So you don't really need load balancer here because servers can have like a load balancer. And at the downtime, right, when your primary machine is gone bad, is done, what happened is the server knows who's the standby promote itself to be primary, and the server knows to go to that guy. And then the backup directory also point to the shared location for the backup file.
And in that case, the standby run that in which kind of protection mode?
The question is, in that case, which mode is that standby running in, right? In that case, standby promote itself to be primary. It becomes primary. You check the status, that machine is called primary.
But it's going to be on the protection mode available, or is on the performance, or which kind of the three you advise for the standby to run?
Which basically this standby machine. It's a question. The question was what mode is it running? Right? How you identify itself to be primary? What did we do internally? Basically, this standby machine. One is a standby only streaming from the primary, and then now it becomes primary as it become rewrite mode for the database to communicate with server. So it can take the request to write to itself to become a primary. Does that answer your question? We can talk about more details after this exactly.
Does that happen right away, or is there a delay?
The question is there a delay or is it happen right away? Actually, that's what we're going to talk about next. What happens at downtime?
Because when you got the loss of the data,
Yeah.
the system can, if it's in the protection mode, it's going to stop instantly.
So I think your concern is there any data loss in this case, right? When we promote it. Let's talk about this case. How we, what happens at a downtime? What do we do at a downtime? It's a very key point for the data store. It's different from portal and server. A portal and server is one machine is done, the other machine take a request. No happening, a little bit failover at the portal inside. But for a data store, when the primary is done, it's as you're concerned about data loss, right? It's pretty expensive for the failover. For a database, failover is very expensive because when you bring the standby, the primary come back, the primary becomes standby, you stream the whole data back. It's a very expensive process. It also depends how big your data is, but generally, database failover is not something you want automatically to happen. What we deal with here is it only happens when it's we call it crash. Your computer is crashed. You're unplugged, someone kicked your computer. So the network is broken. It's all something you are not expected. Only at this time we fail over. If you do it yourself, you gracefully shut down, you stop your data store service, we consider that you are controlling it. You probably want to update your Windows security or whatever. You want to do that. We don't fail over in that case. In this case, we think you are doing something maintenance yourself. And in that case, we don't fail over. The standby is still standby. At that moment, what happened to your application is there's no data. You cannot read it, right? So there's no data written to the standby. So there's no data loss because no data written to it, and the primary is still primary, standby is still standby. It only happens when this disaster happens. It really fail over. That also depends on the data, but take about around 2 minutes. This in that 2 minutes, it's not weirdness. It's just no data show up because we are doing this failover thing. When there's no data show up, there's no data loss because you cannot write to it. You can read to it. There is a 2 minute. You can consider that downtime because the application show up empty. No data if you're coming from the data store. This is the data store failover behavior. What I'm talking about here, you can go to our documentation and search the failover scenarios. We'll come up exactly what scenario failover. So as an administrator, you keep that in mind. This is very important, right? When do you want to failover? How do you want to failover? You control that. We give that control to you. Now we talk about these 3 tiers. We put it together. This is our Web GIS high availability deployment. You can see that all of them, 2 of them requires load balancer, and all of them require a shared directory for shared contents. And next, we'll go over some important factors that I think is very important for when you implement high availability. What we discussed here It's just part of your Web GIS high availability, right? We only talk about a Web GIS tier that we implement, that we know the best as our product. There are other tiers that's very important. First, your data, your geodatabase, your file-based data. You are in charge of that. Make sure they are highly available. And the software, your web server, if you use your if you use a web adapter, and the software load balancer, and hardware, is your file server highly available? Is your network highly available? And sometimes people don't think about it as people. It's very important because high availability generally is has a pretty higher requirement for the skill set. Is your IT people have the skills to implement this? And is these people highly available? If the main technical guy on vacation, anybody cover him? These are the things you keep in mind. They are very important when you implement your high availability. And as we discussed, as David mentioned, when those 99 whatever percent 9, you added a 9 to your availability promise, your SLA. The cost goes not just double; it's a lot. You want to have very disciplined IT governance to ensure the effective or efficient of the deployment you implemented. That you want to be your procedure, your policies, you planned it very well, you evaluate it very well. It's very expensive, and you really need a high availability. Or if you're just your office, right, you few technical guys, you have 2 hours downtime in the middle of the night. Is that okay? It's probably okay, right? You back up and you restore. That's much cheaper to implement. Just what's your happy point, right? Some of our clients, they for example, 911, they cannot have downtime, right? They just pay whatever money they want. They have to implement that. Really evaluate your business, evaluate your requirement. What's your happy point of your requirement? And then when you planned very well, you really update your documentation, your procedures very well, and you document it very clearly. One thing very important is you test it. Like the fire drill, right? You don't just implement it and you just leave it. You really test it to make sure when disaster really happens, it's really going to work. And then you exercise with all the staff that involved. This is very important, the IT governance. Keep that in mind while you implement this high availability. Okay, this is our session for high availability. We talk about all these features you implemented, but that's in one data center, right? In your West Coast, let's say. And then something disaster happened, your whole data center gone. Not just single point of failure, all point has gone. At this moment, for some real important, very high availability requirement to business, you probably want to implement more to ensure your business continuity. That's what John's going to talk about, this disaster recovery.
Thanks. You switch to 5. Thank you. All right, so David covered backing up and restoring a single Web GIS. So in this session, we're going to talk about disaster recovery in the sense of geographic redundancy. Here's an overview of what we're going to discuss. We'll talk about what is geographic redundancy, so what it means to be geographically redundant, and how this affects the complexity of your disaster recovery plan. We'll take a look at how the disaster recovery tool can help you achieve geographic redundancy. We'll look at a roadmap to becoming geographically redundant for your Web GIS. And finally, we'll cover how to recover from a failure. So here's just some background on geographic redundancy. Typically involves 2 data centers in different regions. So for example, one on the East Coast in Philadelphia, acting as, let's say, the primary data center or the active data center. And another in Denver or somewhere in the West Coast or Midwest, acting as the passive or standby data center. If the primary data center were to go down for any reason, natural disaster, or it's rendered inoperable, you can fail over to the standby data center for minimal downtime and data loss. So typically, components within data centers are also going to be highly available, as Cherry went over. So not only can organizations fail over individual components within a data center, but they can then fail over entire regions or entire data centers if necessary. There shouldn't be any loss in functionality, data, performance, scalability, so it's really important to duplicate the configurations between your active and your standby data centers, or your primary and secondary data centers. The number of machines and the requirements for replication typically make this a more complex disaster recovery option. And prior to 10.4, prior to the Web GIS DR tool being available, there was really no way to back up a full Web GIS and all the relationships and different components and then restore them if there was a failure. And nor was there a way to move content, users, services from one Web GIS in an active data center to a standby Web GIS in a standby data center. So the DR tool was developed to cover both of these types of scenarios. So here's this, let's take a look at how you would achieve geographic redundancy using the DR tool. And this is a theoretical way it would work. So you have a primary data center or a blue site, and this you have a highly available portal, multiple machine server site, maybe highly available data store. And it has, let's say, an IP address of 192.168.0.0. And you also have a standby data center with a Web GIS. This also has a highly available portal, multiple machine server site, and a highly available data store. And this has an IP address of, let's say, 192.168.0.1. In front of that, you have a traffic manager or global DNS. And it's assigning the webgis.com domain the IP address 192.168.0.0. So any traffic going to webgis.com, let's say to portal or to server, is reaching the primary data center. Using the DR tool, you're creating snapshots. You're creating full snapshots of your whole Web GIS, and you're applying those snapshots to the standby data center, and the Web GIS in the standby data center. If there was some sort of catastrophe, your primary data center was rendered inoperable for whatever reason, you could then update your traffic manager to point to the IP to assign the IP address of the standby data center 192.168.0.1 to the webgis.com domain, so that all new requests will go to the standby data center. It's all up to date with the most current data because it's in the snapshots, and normal operations can continue with minimal downtime and data loss. So how to actually achieve geographic redundancy using the DR tool. Here's just a roadmap for it. We're going to go into each step in a bit more detail. So the first step would be duplication. You want to make sure, again, that there's no downtime, no differences in performance or configurations between the two sites. Next, you would want to start creating the snapshots. This, again, is typically done and ideally done through a scheduled task to either a Windows task scheduler on Windows or a cron job on Linux. So you would take these snapshots and then make them available to the standby Web GIS. Once the snapshots are available to the standby Web GIS and the standby data center, you'll apply them. And there's two different approaches. Either apply them as soon as they're ready. Again, this can be done through a scheduled task. Or you can apply them when necessary, so in the event of a failure. And we're going to cover the benefits and the downsides to each of these approaches. And finally, you're going to have to monitor your components within your Web GIS to know when a component fails, and to address the problem, and also to determine if that failure or a series of failures warrants a failover to your standby data center. Some of these are going to be manual processes, and some can be automated, so we'll cover that in a bit here. So the first step is duplication. And for duplication, at the first release, the 10.4 and 10.4.1 release of this tool, there is a requirement that you have identical machine names between the two data centers. And this could be a problem for a lot of organizations who maybe they have the same machine, they're using one domain for the different data centers. And this can be achieved in a few different ways. One is using DNS zones within the same domain. So you can have duplicate names even though they're under the same domain. And there is a purpose to this requirement. As this is the first release of the tool in 10.4 and 10.4.1, we wanted to make sure that we're focusing on making sure there's no functional issues with the tool, making sure that it's simplified and straightforward, and limit the variability between the data centers to make sure that there is successful runs of the tool. Another requirement is to have the same number of machines between the data centers. And this is important because you don't want any drop in redundancy, let's say for portal or for data store, or drop in scalability for server. If you have a 2-3 machine site to accommodate user load on your primary data center, You're going to also want to make sure that you have 2 or 3 machines on your standby data center in case there's a failover event. You don't want to drop in performance for your users reaching your services. So the next thing you want to make sure is duplicated is the URLs within your Web GIS, the URLs that your Web GIS is configured with. Now, for example, on the portal side, you have the public portal URL. And this is the entry point into your portal. It's what users reach to reach the home page, to reach their content, their web apps, and web applications. If there is a failure event and you have to switch over to the standby data center, you want to make sure that the users reach the same URLs to reach all their content and the home app. You don't want to disrupt anything within their workflow or how they go about their business on a day-to-day basis. Within a portal, you also have a private portal URL, as Cherry mentioned, and again, it handles the communication between the server and the portal. Because we're taking a full snapshot of the primary Web GIS, that property is going to be within that snapshot, and it's going to be simply applied on the standby. So it's important that the property is the same between the 2 Web GIS sites. Next, on the server side, you have the services URL. This is very similar to the public portal URL. It's the entry point to your REST directory and your services. And your user, they're going to be using this URL to add services to your web maps. And if there is a failure event, you want those web maps to continue to work. You want them to be able to still reach the same services directory to access services, and you want the web maps to continue to function. So it's important that the services URL used within server is the same between your primary and standby Web GIS sites. Next, within Federation, you have the admin URL. This is the URL that portal talks to server with. And just like the private portal URL, this should be the same between the 2 data centers. Again, because you're taking a full snapshot and applying that snapshot, you have to make sure that you're using the same admin URL within any federated servers. Next, you have a bunch of dependencies within services, paths to data within, on a Windows share, or connections to geodatabases or databases. And if those same connections and file paths don't exist on your standby, if you do have to fail over, some of those services aren't going to work anymore. So it's important that those dependencies are met and those requirements are met for data access on the standby Web GIS. So duplication is going to be a manual process. You have to make sure that you spin up the correct number of machines with the correct machine names. You have to configure your Web GIS. You can do this configuring the Web GIS can be automated using Chef, which there have been some sessions about. But it also does involve making sure that the Web GIS is configured correctly, even if you're doing it in some automated fashion. At 10.5, we wanted to focus on a few things. One of them being, a simpler approach to configuring your 2 different Web GIS sites. And to do this, we're removing the requirement to have different machine names. So you can have, let's say, P1 and P2 on your primary Web GIS as the portal machine names, and P3 and P4 on your standby Web GIS for the portal machine names. Also, the private portal URL and the admin URL used for federation can also be different. Organizations typically have different load balancer machine names between 2 data centers. So that's something else that is going to be supported at 10.5. So once you've duplicated your environment between your primary and standby data centers, the next step would be to start taking snapshots. This follows the same approach as backing up the Web GIS if you just have a single deployment. And it's all done hot, meaning there's no downtime for the primary Web GIS when you're actually creating these snapshots. And it is going to be a full snapshot at this release. So it's a full snapshot of all the data, users, services, data within data store. It can be scheduled as a Windows task or a cron job on Linux. And again, that's what we recommend. And for data store, when it's exporting the data store, when it's creating a snapshot of the data store, it's going to create a snapshot of all the data within the data store, so any data that's used within hosted feature services. It's optionally going to create a snapshot of all the data used in scene services as well. On the server side, it's going to export the site configurations, services, and any data copied to the server during the publishing time. And finally, for portal, it's going to create a snapshot of all the content, users, groups, item information. So the time to create the snapshot is going to be dependent on the size of your Web GIS. It could range from tens of minutes to up to an hour or more. If scene services are being used and you're including those within the snapshot, those can take up the majority of the time to actually create the snapshot, and as well as dramatically increase the size of the snapshot due to the size of the scene service data. So it's important if you're going to be doing this through a Windows task or a cron job to define a different schedule for exporting or creating the snapshot of your scene services than the rest of your other data. So for example, you can include the scene service within your snapshot once a week, but then every other time you run the tool, you're not including the snapshot. No, I'm sorry, you're not including the scene services. So it's also important to make sure that the snapshot is going to be available to your standby Web GIS. Either putting this in a share that's accessible by both data centers, or by moving it through some automated process. So it's important that you make sure that the snapshot is going to be available to the standby. At 10.5, along with just an easier approach to using the tool between two data centers is performance improvements. So we're introducing delta changes for portal server and for data store. What this means is that you can create a full snapshot of your Web GIS, and then for subsequent snapshots you can do incremental backups or incremental snapshots. And this is only going to capture anything that has been changed, added, deleted, or updated within your Web GIS. So once you've created your automated processes to create the snapshots, the next step would be to apply them. First, again, make sure that it's available to your standby Web GIS. And then you can start to apply these snapshots. And something to keep in mind is that at this, this release, and even in just importing a full snapshot, it's going to be deleting everything on the standby Web GIS. So it deletes everything and then recreates everything. So if you are using that standby Web GIS for any reason that you're creating content, you're creating some test items or services, they're not going to exist after you run the full, after you apply the full snapshot. There's two different approaches to applying snapshots. Either you can do it through a scheduled task, or when there's a failure. The benefit of doing it as a scheduled task is, again, it's automated. You don't really have to think about it. It's immediately applying the snapshots when they're ready, and it minimizes downtime because you know that the standby Web GIS is going to be up to date with the most, all the current information and current data. The downside to this approach, though, is that it is an automated process, and if any changes have been made on the primary that have been incorrectly done, or any data that is corrupt on the primary, that's automatically going to be included in the snapshot and then automatically applied to your standby. So something to keep in mind. So the other option is to apply the snapshot when there's a failure. In this approach, you notice a failure on your primary, you apply the snapshot, and then you can fail over to your standby data center. The benefit to this approach is that you know specifically when you want to apply the snapshot, and you can specifically choose what snapshot to apply, so you know it's good and you know it's valid. The downside to this is it adds a bit more downtime, because again, you have to make sure that you apply the snapshot first to your standby and then go through your failover. So there is a potential that adds a bit more downtime. We do recommend that you use the automated approach. Again, the idea is minimizing downtime. So by making this an automated process, you're making sure to minimize the downtime for your Web GIS. There are some things to keep in mind, though. You have to understand you have to know how long it takes you to actually create the snapshot and apply it. You want to make sure that your schedule and your backup schedule and your schedule for applying them, you're not kind of running over jobs. So you're not currently applying a snapshot and then your scheduled task kicks in to apply another snapshot. You want to make sure that you know how long it takes to finish, maybe add a little bit more buffer time. So applying the snapshot is going to take much longer than actually taking the snapshot. Could range from tens of minutes to up to an hour or more, especially if you're including the scene services. So it's something to keep in mind when you're scheduling these tasks. To address performance, again, delta changes are going to be introduced for applying the snapshots. So after the full snapshot is applied, anything that has been added, and you take an incremental snapshot and you start to apply that incremental snapshot. Anything that has been added on the primary will be added on the standby. Anything that has been deleted on the primary will be deleted on the standby. And anything that has been updated on the primary will be updated on the standby. But anything that hasn't been touched simply won't be affected on the standby. So that should help in the time it takes to actually apply the snapshots. So now you have your automated processes to take the snapshots and apply them, and this is working well. But at this point, you need some way to make sure that your standby Web GIS is up and running, and you're also monitoring all the components on your primary Web GIS. And this can be done in a few ways. First, again, you should have some sort of QA processes on the standby Web GIS to make sure it's up and running, and it's accessible. The items are being copied over correctly. This can be done through an automated task to check for certain items. Or, for example, generating a token on the portal or the server and accessing some content that's secure, a secure service or a secure item. You could just try to publish a test service, make sure that works. So the next thing to do is making sure you're detecting when individual components within your WebGIS failed. This is important because, as Cherry mentioned, you have two, let's say you're in a highly available configuration for Portal. If one of those machines were to go down and you have no way of monitoring that, you have no way of being notified of that failure, then you're in a position where you have a single point of failure in that lone remaining portal. So it's important to make sure that you're able to detect when there's a failure within your WebGIS. This can be done using the health check URLs within Portal and Server. And this can also be done by checking the data store using Server Admin, validating the data store, make sure that it is healthy. Monitoring is done using the tools within your organization. For example, if you're going to be using a load balancer or reverse proxy, health check mechanisms within those different components can help you check the health of these different Portal and for Server. You can also use some automated scripts like a Python script on a scheduled task to check the health check URLs, maybe query the Portal or Server logs, or validate the data stores. And finally, if you are noticing a failure, failing over whole data centers should be a manual, deliberate decision. It could be a very expensive operation, very time-consuming. So you should be sure that failover is actually necessary. This is by making sure that, again, the primary is in a state that failover is necessary, and the standby is in a state where it can become the primary. It's up and running, not having a snapshot applied, those types of things. So let's say that at this point, you did have a failure event. You have failed over to your standby data center. Well, how do you actually get back to the primary being your primary data center? A lot of organizations, they do have a single data center that they typically have as their primary data center. The first thing to do is to make sure that you've stopped any of those automated processes that are applying snapshots on the standby data center. Next step would be to bring up your standby data center. The primary data center. Make sure that on the data center level it's up and running. The next step would be to set up your WebGIS, configure it identically to as it was before, identically to the standby WebGIS. Now at this point, because you've stood it up again and it's working, you want to stop any of those automated processes to create the snapshots if they're still configured. And at this point, people are using your standby data center and they don't know that there has been a failover event. They're still creating content, they're still creating services, and you don't want to lose any of that data. So what you can do is use the disaster recovery tool to create a full snapshot of all the data within your standby WebGIS and then apply it to your primary WebGIS. At this point, because the primary WebGIS has all the updated data, all the current data, you can then fill back your traffic manager or global DNS to point back to your primary WebGIS. At this point, you'll resume any of those automated workflows and automated processes to create snapshots and apply snapshots. So again, just a quick review. First step is make sure that your primary data center is operational. You want to make sure it's up and running. Next, reconfigure your WebGIS identically to as it was before, and make sure that it is, again, up and running. Next is to make sure that any content is replicated from standby to your primary. You can update the traffic manager, again, global DNS, to point back to the primary. And then you begin your replication workflows to move snapshots from your primary to your standby. So here's some important points that you want to keep in mind. It's important to have an IT staff that's prepared to handle geographic redundancy as your disaster recovery option. It's important that they have an understanding of how to replicate file servers for any of that file-based data or file databases or shapefiles. It's important that they are familiar with replicating databases and geodatabases, again using the tools available within those databases. They should have a familiarity with the Web GIS in general, understanding the different components, how they interact with each other, as well as have familiarity with monitoring tools. This is through load balancer or reverse proxy. You have to be able to know when these components fail. Any custom scripts or processes can achieve this. It's also important to run drills, as Cherry was mentioning. You want to eliminate as many unknowns as you can within your disaster recovery plan. By practicing, you can identify the areas that need improvement within your plan. Finally, not finally, but take advantage of the Web GIS Disaster Recovery tool to replicate your data between your primary and your standby. The DR tool was built to capture all these configurations, all these relationships within the components in your Web GIS, and either backup and restore or apply them to a standby Web GIS. Determine a schedule for taking and applying snapshots that works for you and your organization depending on the size of your Web GIS. Understand how long it takes to create the snapshots and understand how long it takes to apply them as well. And finally, geographic redundancy is very complex. You have to have the same number of machines, you have to set up two whole different data centers, and consider if it's a necessary option for your disaster recovery plan in your organization. So with that, hand it back over to David.
Well, thank you, John. Cherry just wants to prove that her demo actually succeeded. She forgot to show it. So.
I promised to come back to show you. Now this is how it looked like after it successfully joined the portal, and then in your portal administrator, this is how you see. Now you have two machines, one primary, my standby. I just want to show you that. Go back.
Okay, thanks, Cherry. Before we take questions, I wanted to mention a few things. The first is, the way I see this session is this session's the beginning of the road to high availability and disaster recovery and backups. You're obviously going to go home. You're going to have additional questions that didn't occur to you when you were sitting in the audience. You're going to look at the documentation, you get deeper into it. If you have additional questions, I'm going to have my cards out here. We'll all have our cards out. Feel free to take them, and feel free to email us. We also have great technical support. So if you get to an issue and you need to troubleshoot it, our technical support is very versed on this. John did a presentation for them recently, and we help them troubleshoot stuff all the time. So please do take advantage of that as well. I want to encourage you to fill out our survey. The survey is all electronic this year. It's on your smartphone on the Esri Events app. And you can look up this session, and you can then rate it and give it a number score. And you can type in some comments as well. The comments, we usually look at them when we're planning for next year. So we're looking, like, for your suggestions, was there content that was confusing, additional content you want to see? Was the level too advanced or too easy? Just put any comments you want, and we'll look at it and take it into account for next year's session as well. With that, why don't we just open it up to questions, if there are any. Yes?
Can we use the Web GIS disaster recovery tool without ArcGIS portal or ArcGIS data store?
The question is, can we use the Web GIS DR tool with just without portal involved? The answer is no, because like we showed in that tool, it only takes in that portal URL and it gets the information about all the other components there. For server, what you'll need to use is our backup and restore utility to do that. If anybody has questions or they want to share something privately, just feel free to come up right now then. Thank you guys very much.